LiveFront. We're a company that helps other companies design and create beautiful apps. We're lucky to be one of the sponsors again this year for DevFest. We've downstairs, so come talk to us or find one of us here for the rest of the afternoon. I want to put in a plug for Brian's talk later this afternoon on Android lifecycle. I'm sure that will be very interesting. I also want to put in a plug for TC Hack. The website down there for more information is tchack9.com. It's a monthly get-together of developers just want to come together, work on their own stuff, work collaboratively with other people. There's always beer and pizza. We had the mobile hack is the first Wednesday of each month, and there's also a Rails hack later in the month. So let's get to it then. Sometime this summer or fall, last fall, I read something that Google was introducing to Google Vision API, and I got really excited because I'm a big fan of computer vision in itself, and I could see myself giving a talk titled "Everything from Barcodes to Face Detection," but with a little more reading, I came to realize that everything means just barcodes. So Google introduced the Mobile Vision API in version 7.8 of Google Play Services back in August of 2015. And still only contains the Face API and Barcode API at this point. The only improvements have been some bug fixes. So I'm not sure what Google intends to do with this Mobile Vision API, whether they just keep maintaining it, fixing bugs, or if they will try to introduce something more than just barcode readers and face detection. So a better title for this talk is probably just one person's experience in learning about and using Android's Mobile Vision API. So I've split this talk into the two parts, barcodes and face detection. It splits up pretty nicely with that. We're going to start off with barcodes. Now, when you think of barcodes, you just think of these little static images. Usually scan them. They're on boxes and books and whatnot. And you would think that detecting that would be easier than, say, a face that's moving around, has different features. That's what I thought too. But it turns out that barcodes aren't the easiest, as we'll see, to detect. So there's great support for barcodes with the API here. You have a bunch of 1D barcodes up above, A9, 13, 8, some UPC codes, and then a bunch of 2D barcodes down here at the bottom, the QR code, data matrix, PDF 417, Aztec. I have used almost none of these, but the support is there for them. The 2D barcodes are actually kind of neat, depending on what's been encoded in them. The barcode object that you'll get back from using the barcode API will actually contain lots of useful information. For example, well, the barcode can contain any of this stuff if it detects it as some encoded information. So you can get a calendar event back, contact info, driver's license, email address, location, phone numbers, SMS, just plain URLs and Wi-Fi. So the barcode is definitely useful. The question is, how do we get at it? Before I get into that, I want to talk a little about static versus dynamic detection. And even before I get into that, I want to talk about just my experience building the app, the sample app that I developed for this talk. So, honestly, when I first started out, the app was just a mess. So there's face detection and barcode detection. So I wanted to certainly include those two things in the app. There's also multiple types of detection. There's dynamic detection, which would be like a camera. And then the Mobile Vision API also allows using just plain bitmaps. So that would be the static input. So you can get bitmaps from assets and raw resources, or you could just pull a bitmap down from an image on the web. So the app had face detection, it also had barcode detection, and between those two it had the static and the dynamic inputs. So there's 4 distinct parts to the app. And as I said before, it was just a mess. It was just 4 different apps glommed on together. The only thing they really had in common was that each fragment belonged to the same view pager. So there was just a lot of code, repeated code that didn't do much. But with a little more research, a little more review of the code, I was able to consolidate most of the code down to a few base classes that do all the heavy work. And I was able to realize that barcodes and faces are pretty much the same thing. They're just objects that get sent back from a detector, and then you want to do something with that. You want to display it on the screen. So whether it's whether it's a face or a barcode, they can both extend from the same base class. And so adding, for example, if Google decides to add another object detector in the future, it would be easy to extend the base class that gets created and add support for another object. So as I said before, there are multiple methods of input. There's static, just bitmaps, and then there's the dynamic camera. Part of the realization that I came to is that once you have this barcode or face, the post-processing and display of this is pretty much identical. So those can be combined into one. And as I mentioned before, the only difference is the input process. So actually, let's look at the input process here. This is a very nice flow diagram that Google has provided. On the left side here is the input from the camera, and all the way on the right side are the graphics that get displayed on the screen. So for the next few slides, we're just going to talk about this processing pipeline. That's their term for it. And this is really the basis of how they want the app structured, and which I completely ignored when I first started developing the app. We're actually going to start in the middle of this process. We're going to look at the face detector and something called the multiprocessor. So for the face, we're actually talking about barcodes right now. So in the diagram where it says face detector or face tracker, that'll just be the base barcode detector or barcode tracker. So here we have just a basic fragment. During the initialization of it, we can create the barcode detector, and that's very simple. That first line there, really, barcode detector equals, and then you grab the builder for it and just call .build. We also need something called the barcode tracker factory. We'll get to that in the next slide. But the important thing there to note is that we're sending in something called an overlay. That's just a custom view that's going to hold all the graphics that get generated when we're doing the barcode detection. And then we need to combine the barcode detector and that barcode tracker factory by calling set processor on the barcode detector. So here's the barcode tracker factory. As the name implies, it's solely responsible for creating barcode trackers. So when the barcode actually detects when the barcode detector actually detects a barcode, it'll go to this factory. The create method will get kicked off, and then down here in the create method, we're creating something called a barcode graphic. We'll get to that in a couple slides here. We initialized with the overlay that got sent in originally, and we also sent in the graphic. So that will reboot the barcode tracker. We'll see what that actually does here in a little bit. Before we get to that, though, let's step backwards in the process to the input. We have a camera source and a camera source preview. The camera source is just responsible for taking in input from the camera and sending it onto the face detector. I'm not sure exactly what happens in the internals there. I'm thinking it has something, it grabs the frame from the input and then sends it onto the detector in a way that it knows about. And then the camera source preview here at the bottom, that is just another custom view. It holds the surface view, so when you're using the camera, that'll be the thing that you see. And then it knows about the camera source, so it can send on its everything into the camera source. Okay, so we're back into the fragment, the initialization. The first method there is the create camera source. So the first part of that is the barcode detector that we looked at before, and the creation of the barcode tracker factory. So once we have that, we can just grab the builder and the camera source, send it to the barcode detector. And the builder has a couple key methods that we want to make use of. We can set which direction the camera is facing, whether back or forwards. We can also set the preview size. You can set this as big as you want. The bigger it is, the more detail the detector will be able to pick up on and possibly be more accurate. It'll also slow it down and use more memory though, so you'll probably need to work with what's best for you. You can also set the requested frame rates per second. You can also set that as high or as low as you want to. The thing to remember there though, if the back end can't keep up with the number of frames being sent in, it's just going to drop it. So it's not going to lag, but you're going to lose any that's sent in with those frames. And then there are also some nice to haves like autofocus, and I think there are a couple other ones that I omitted here. So once we have that created, we can just call .build, and then we can start the camera at that point, the camera source. So we had the preview, like I mentioned before. And all we do, that's, as I mentioned, a custom view with a start method. So we just send in the camera source in there, and we should be good to go. So here we're back on the graph, or the flow diagram. So we have the input to the camera source. That's got sent into the face detector. Face tracker factory has created a face tracker for each face that we've, or barcode that got detected. And that, and then the factory creates those trackers on the right side there. So let's actually see what those trackers are doing. So the barcode tracker here extends a tracker method. And there are 4 different methods, or the tracker class, there are 4 different methods that will get called on this when a barcode isn't detected or something happens to it. The first method there, on new item, that gets created, or that gets called whenever a new barcode is detected. Here we are, we'll get to the graphic in the next slide, but we're just setting the unique ID on that, just for display purposes. The next item is on the next class, the next method, that gets called is on update. That gets sent in detections object, which contains metadata about past detections for this barcode, and then the barcode itself. So on update gets called after a new item. Each frame that barcode is detected in, it will call this on update. So you're always going to have a handle on that. Here we're just adding that graphic to the base overlay, so something gets displayed on the canvas. And then on the graphic, we're updating the associated barcode with that item that just got sent in. And 2 other methods here, on done and on missing. Those get called when something happens to the barcode. On missing gets called if it's absent from 1 or 2 frames. And then, so in that case, all we're doing is calling remove that graphic from the overlay. I'm just going to remove it. And then undone gets called when the detector determines that that barcode is never coming back. So let's talk about the graphic, the barcode graphic. So here's the base graphic class. It's pretty simple. 2 methods to note here are the update item method, as we saw in the previous slide. That gets called when on update is run. So what happens there is we're setting the member variable to the barcode that got sent in, or the face, or whatever we're making the graphic on. And then we call post invalidate. Post invalidate will tell the base overlay to invalidate itself, so it will redraw, and in that overlay's draw method, it's going to call out to this draw method for each associated graphic. I should mention what gets sent in here. So we have the canvas that we're actually going to draw on. Then we have a few variables to help us determine where and how big stuff needs to be drawn. So there's a scale value, delta x and delta y, that kind of fudges where on the screen it needs to go. It also sends in the camera direction, either forward facing or backward facing. And then another flag that I added is this thing called single item. That just tells the graphic if it is the only graphic in this overlay. We'll see later, not with barcode stuff, but with faces, that I use that to draw more information if only one face gets detected, for example. So the actual barcode graphic class is pretty small. It extends that graphic base class that I showed before. All we're doing here is we're drawing a rectangle around the barcode and drawing the raw value for the text at the bottom. So the barcode item there has a handy method called getBoundingBox that'll actually return a rect with the dimensions and with the positions on the screen that you need. So we scale that up or down depending on what we need to do, and then we just draw the rect where it tells us to. And then we do the same thing for the text, the raw value. As I mentioned before, the barcodes have more than just raw values. Sometimes, if they're some of these 2D barcodes, we're just ignoring that for now, but you can do something nice with that. Display more information if you want to. So with all that work done, the final payoff is me trying to scan a box of crackers. As you'll note, it's not doing very well. You can kind of see it flip on once in a while. We'll see the face detection actually works a lot better than that. I don't know why exactly it's not working. Could be the lighting isn't very good here, or I don't know if the autofocus was not working right. But either way, to actually get the barcode scan, it took a while. I also added a gesture detector, so when barcode does appear, you can tap on it and it'll show this toast on. I don't know if you can see it down below. It's just an example of what you can, the very simplest thing you can do with this barcode detector. So that's the dynamic input. We can also do stuff with static input, as I talked about before. We can kind of use the same underlying structure, but we can take out this entire middle part. We can go straight from the barcode detector to the graphics that get displayed on the right here. And the code to actually do that is pretty simple. This is a new fragment here that we have here. So this chunk here, we're grabbing a bitmap, what are they called? Barcode example, from raw resources. Convert that to the bitmap. We build the barcode detector in the exact same way, but this time we create something called a frame, and we set the bitmap that we generated there. And then the detector has a method just called .detect, and then we can send them the frame. And from that, we get an array of barcodes back. So now that we have those barcodes, we can manually create the graphics that the tracker was doing before. So we just iterate through that array of barcodes. We create the barcode graphic, sending in the space overlay that we had before. And then we manually call update item with the barcode that we just found. Something different for this overlay is that we need to call set content. We pass in the bitmap so that it can draw that itself, and then the set of graphics. And then that overlay will work just like the other one. On its onDraw, it will call the draw of all these graphics that it's associated with. So the only new stuff here is this initialization code, and I have another overlay that's a little different, but it's pretty much identical to the dynamic version of this. So we can see some output here. The example I used actually had two barcodes here, and it was able to detect it both accurately and see the red outline there. It's very accurate. So static image stuff, much simpler than I made it originally. And yeah, it's pretty simple to set up. I wanted to, if the barcode API doesn't fit your needs, I wanted to just throw out a couple of alternatives. A couple of big ones are zebra crossing and zbar. They both support most of these barcodes, if not all of them. And both of them have some type of default behavior baked in. They might even have a default view that you can include, or they have connectivity that you can call an intent to. It'll do its thing, and then return the result to whatever it's calling it. So that's nice, but you might lose some customization, the ability to customize it, and it's just another library to add. With the Barcode API, it's part of the Google Play services, so it's included by default. Although if you're picking and choosing the libraries from that, the Barcode API itself is another library, so that's up to you to decide if you want to do that. So that's all the barcode stuff I wanted to cover. The lessons we learned there, though, will apply directly to face detection. So this next part of the talk will focus on that. I want to mention this is face detection, not face recognition. So the API will let you know if something is on screen, a person's face is on screen, but it won't tell you who or what that is. I'll get into the actual app here now. So I wanted to make it easier to test out these face API features. I wanted to start with the static images this time. So I wanted a large number of static images that I could repeatedly run the different face detection methods on, the features on. Fortunately, I did have a large test set. When I had my daughter, my wife took weekly pictures. So if anyone wants to sample that, there's going to be a test sample or a test set of 52 images here. So I just threw those into Recycler View, and hopefully, my initial thought with this was that the face detection would slowly get better as the weeks went on, as Zoe's face became more distinct. As you'll see, that's not really the case. The face detection actually works from the very beginning, so in terms of baby faces, it does a good job. So here's the initial code. It looks a lot like the barcode code. In fact, it's nearly identical. So instead of a barcode detector, we have a face detector. We're still setting up the frame the same way. The detector throws back a sparse array of faces, and then we iterate through that and create face graphics rather than barcode graphics. I guess the only thing to mention here is that since we're using a recycler view, each internal view has its own view holder with its own overlay. So we need to actually go into that rather than one big overlay. And then this is the face graphic draw method. This looks remarkably similar to the barcode graphic as well. Instead of get bounding box, the face actually has a method called get position that just gets the upper left point of the the face, excuse me. And so then we can do adjustments based on which way the camera was facing, forwards or backwards. And then from there, in this initial version, I just have it drawing a rectangle around the face. So we can also get the height and width. Oh, isn't that calculations up there? So we can get a nice rectangle around the face. So let's see what that looks like. So as I mentioned before, it did a good job right from the start. There are a couple images where it couldn't detect the face. I'm not sure if that's because of shadow or if it's because just the nature of a baby's face, it doesn't always look like a real face.
That's the problem.
So I'm not sure exactly what, but in general, it does a really good job of detecting where the face is and if there is a face. One thing I should mention, you actually shouldn't be doing face detection on recycler view. It's resource intensive, so you'll notice the jitteriness. It's going to slow it way down. So if you, for some reason you do want to do this, I would recommend caching the results in memory. The face API doesn't have anything built in for that. You have to do something yourself. What I did was create a hash map mapping the position of each image to the result of the face detector. And each face object is pretty small, so you're not going to run into memory issues really. You can see what that looks like once the cache is in place. You'll notice the first time it goes through, it's still going to be jittery because it still needs to do that face detection. But then once that's done, you can scroll. The scrolling is pretty smooth. And here we got some more images that we haven't done face detection on. So then we scroll back up. That's nice and smooth. So in general, don't do this on recycler views. Use the camera or do it on just one static image if you need to. So that's the basic face detection algorithm. Something a little more interesting are landmarks. So landmarks are features of the face, interesting features of the face, such as the eyes, nose, mouth, those types of things. One thing I should mention, the face API, when it does face detection, it detects the face first. It doesn't care about any other landmarks. So if we do want to enable these landmarks detection, we have to. That happens after the face is initially detected. So it does add a little more processing time. Not much, but I just want to mention that we don't get it for free. So once you set the landmark type to all landmarks, I think it defaults to something called like no landmarks. So once we do that, we can add something a little more to our draw method for the face graphic. The face object has something called get landmarks. That method returns an array or a list of landmarks. Then we can iterate through those and then draw those on the canvas just like we drew that rectangle. The landmarks you can get the type and the position from it. In my example, each landmark I made a different color so it'll be easier to see what's what. So the first thing I'm going to start off with are the eyes. So the two landmarks there are the left eye and the right eye. We can see that at play here. That's actually pretty accurate, although a little creepy. I probably should have picked something different than green. She's kind of bug-eyed there, yes. But in general, the eyes are pretty accurate. They're right on. You always see both eyes, except for the images where no face is detected. As I said before, if no face is detected, no landmarks will be detected either. For example, right there. The next landmark is the mouth. The next category is the mouth. The landmarks there are the bottom of the mouth and the left and right part of the mouth. That's a little more hit or miss. It's red, it's a little harder to see on the screen. But in general, I don't know if it's because just mouths in general or her mouth. But it's very rare that you get all 3 points on. And we'll see later when we're measuring smiles, that comes into play in a big way, I think. So the next category of landmarks is the ears, the left ear and the right ear. This is probably the most interesting ear, or the most interesting landmark, just because of something that it reveals about this API. So here, you'll notice that at most only one ear is actually ever detected, and in most places no ears are detected. You would think at some point both ears would be detected at some point. That's not the case though, and the reason for it is this thing called Euler-Y and Euler-Z Angles. On the left, is a nice graph, nice chart from Google explaining what they are. And then on the right is me trying to demonstrate the same thing. So I always get this mixed up. So the Euler-Y angle is the yaw, or what they call the yaw. That is the angle that your face is facing left or right. So let's see. If you're facing right, it is a negative angle. Facing all the way left, it's a positive angle. Straight down the middle is 0. And then the roll is which way your head is actually tilted. Remember which way. So if you're tilted to the left, it's negative. If you're tilted to the right, it's positive. The actual angle that we care about here is the Euler-Y angle. That plays a big part on which landmarks are actually detected. Let's see here. So as I said before, landmarks are detected after the face is actually detected. So depending on the Euler-Y angle, you can see the bottom here. Depending on that angle, only certain landmarks are going to get detected. If your face is all the way to the right, you're only going to get the left side. The left eye, mouth, ear, cheek. You're always going to get the nose just because it's always visible. It always sticks out. As your face moves in, you're going to gain some more of the right side of your face. So if you're between minus 12 degrees and minus 36 degrees, you're actually going to get the right eye at that point. Straight down the middle, as we see in many of the pictures of my daughter, you don't get any ears at all. You get everything else but no ears. And then as you move further left, then you get all the right side, and then you start losing some of the left landmarks. And all the way over, then you just get the right eye, right mouth, right ear, right cheek, and the nose again. So to actually get ears to show up, you need to set the mode of the detector to accurate mode. It defaults to fast mode.
It defaults to inaccurate.
It's faster though. So if you don't set it to accurate mode and you keep it in fast mode, Euler-Y angle gets stuck at 0. So all you're going to get is this middle column here. You're never going to get the ears. So we need to set that mode to accurate. And then once we do that, there are a couple of methods on the face object. Get Euler-Y and get Euler-Z that actually gives you that information. So we're just going to draw that on the graph, or on the image, just to see what's going on. So if I pause it here, so that first image there, I don't know if you can see it, but the Euler-Y angle is 20 degrees. So we go back to our handy chart. 20 degrees puts us in this column, so we should be able to see the right ear tip. And in fact, we do get part of the ear there. I guess that's the ear tip. It's kind of hard to see. And then in this next image, the Euler-Y angle is only 8 degrees. So if we go back, that's considered right down the center, so we don't get any ears at that. The next category of landmarks are the cheeks, the left cheek and the right cheek. This kind of falls into the same category as the ears. 20 degrees Euler angle, you only get the right cheek. Straight on, you get both cheeks. And in general, that's what you get. Straight on, you're always going to get both cheeks. And then to the left or right, you're only going to get one cheek. You're not going to get two. So. And the last thing is the nose base. Like I mentioned before, the nose is always visible, so you're probably always going to get that. That's usually pretty accurate. It's always around the nose, mouth area. So nothing that interesting there. Let's see. So we saw before that there's the Euler-Y angle and the Euler-Z angle. There's other things though that we can get from this space, these spaces. We can set the classification type to all classifications. It defaults to no classifications, I believe. And those get give us a few more properties. We can get whether the user's or the face is smiling, whether the left eye is open or the right eye is open. So I've added some more to the draw method of the face graphic. We can see what that looks like.
It's kind of hard to see again.
But like I mentioned before, the mouth detection was kind of troublesome in a number of these photos. And I think that leads directly to the smiling probability not being always accurate. For that top one, for example, the value is -1. So it didn't even try, I don't think, to detect the smiling. Then the left and right eye open probability, those generally seem to be pretty accurate. For this one down here, it's 0.96 and 0.99. The eyes are obviously open. So in general, the eyes are pretty accurate. And I think the mouth would get more accurate for adults, for example. Those detections seem to be more accurate. So that's all for that part. So here we've seen detection on one face. And we saw multiple detections for the barcodes before, so let's try to find multiple faces for faces as well. So this is part of the live front team. There's Pete and Brian on the left, Mike and Rebecca on the right. The guy in the middle, that's our designer, Andy. I don't know why the face detection didn't work for him. I don't know if it's the glasses or the gear. As you notice, everyone else is clean shaven and doesn't have glasses. So it's kind of hard to tell what exactly is missing from there. But that led me to try to figure out what other types of faces would be detected or would not be detected. So the cat didn't work, the chimpanzee didn't work, the cow didn't work, the dog didn't work, the elephant worked. The gibbon did, though. And the gorilla didn't. It's hard to see what. So it doesn't think the gibbon's smiling at all. The eyes are probably open, and then it's staring straight on pretty much, which is accurate. So in general, you're not going to be using this on non-humans, unless they exhibit extreme human features. So the last thing I actually want to talk about with face detection is something called face tracking. I haven't touched on this yet before, but if tracking is disabled when you're using the camera, the IDs that get sent in, this is the face tracker. The ID that gets sent in isn't going to be unique. It's always going to be, it's always -1. Once you enable tracking, though, your face as it goes around the screen is going to have a consistent ID. I'm not sure exactly what you'd want to use this for, but if you want to kind of track the faces by ID around the screen, this is the way you need to do it. You need to enable tracking, as shown below, above. And then in the tracker, we had already set this, but the graphic then gets a unique ID that gets applied to the graphic. So here's an example of that happening. You can see the ID hopefully at the bottom there. As my face goes around the screen, that ID is kind of consistent. It's ID1. As soon as I go off screen, however, I lose the face, come back on, now I'm ID2. Like I mentioned before, this is not face recognition, this is only facial detection. So it doesn't know that I'm the same face. It just thinks I'm a brand new face. So this works really well with one face, as long as you stay on screen. It runs into problems when you have multiple people on screen and you're crossing paths. Sometimes it can't figure out which ID to pick up or which ID belongs to which face. So you kind of get a mix-up at that point. And anything else here? Put some debug code or debug output at the top there. smiling there. Smile at the very beginning or end. The smiling is more accurate than my daughter's pictures. But that's pretty much all I want to talk about face tracking. So like with barcodes, I wanted to touch on some alternatives to the face API. Really the only one I've used extensively is something called OpenCV. It's kind of unfair to compare the face API to OpenCV though. OpenCV is a complete computer vision library. It's very, very powerful, very configurable. Like, I'm not sure exactly how the face API that Google supplies, what they're doing in the background to do the facial detection. But with OpenCV, you can actually specify and train how faces are detected. You can improve it for faces facing either left or right or straight on. So, as I mentioned, it's very powerful, it's very configurable. It does way more than what you probably actually need though. If you're only doing face detection, this is just plain overkill. And because it's so powerful and so tweakable, it sometimes gets really very complicated to set up and use. So, I wanted to conclude with saying when you actually want to use the barcode and the face API. If all you're doing for computer vision is just trying to scan a barcode or pick up and detect faces, this new API is probably the thing that you want to use. It's very customizable. You can integrate it very closely to your existing app. If you want to do something more though, like a complete computer vision app, this isn't going to be the thing for you. So in general, I guess the conclusion is just use what actually suits your needs the best. And hopefully Google does do something more with this, either opening it up some more or including some more object detection. But for right now, what it is, it can be useful. It can make your app more fun. And I had a few resources here that if anyone wanted to see them. I have made the sample app available on our LiveFront GitHub account, github.com/LiveFront/Android/Vision. There's a couple guides and examples that Google makes. If you type in Mobile Vision API, those will probably be the first two things that come up. So you can either take them down now or just do a search for them. I've also included links to the alternatives that I found. So opencv.org, they have an Android library there. And then Zebra Crossing and ZBar are both available at github.com/game77/barcodes. Hopefully something there will be useful to you if you want to play around with this more. But otherwise, thanks for coming. Any questions? Yeah. You in the front? Yep.
Does the API handle image ones after processing?
I'm not sure entirely. I don't know what internally it's doing. We saw before that shadows might have thrown off the detection, so I don't think it's doing a lot to actually do it. You're kind of more responsible for that when you're setting up the camera and stuff.
So, in addition to the API,
Yep.
do you recommend to add filtration?
I think that would be a good step, yeah, just to make sure everything is getting priced out. Yep.
So if you were working on, like, going to spin up a new greenfield app starting today, and you needed to scan barcodes, all things considered, but the main qualification is that you're lazy, such as myself, would you use Zebra Crossing or the Android Vision API?
I think you could use the Android Vision API pretty easily. You could just run all your assets through that, and then just have those spit out pretty easily. You wouldn't really need a UI or anything, so yeah, I think it would be pretty nice.
Cool, thanks.
Sam?
Performance differences between, was it OpenCV or what was the?
Yeah, OpenCV.
OpenCV versus Android Vision for face detection.
Face detection, the face API is pretty fast, as we saw. OpenCV, I think you can make that as slow or as fast as you want, just tweaking how accurate you want. So if you are just concerned with speed, the Google API is just not going to be as accurate.
OpenCV does a lot more than just face detection, right? Like you can
Yes.
use that for face recognition.
Yep, you could use that to help you with face recognition. So, like I said before, it's a little overkill. It's kind of hard to mirror this you. But
If you're just doing face detection.
Yes.
Right. So you made it clear from the very beginning that it was barcodes or faces.
Yep.
That being said, what would you do if you had a, let's say, like scan or receipt or something?
And the API suddenly did support that?
Or would you know of any APIs that would?
Not off the top of my head, no. I'm sure there are some OCR type things out there. Not that I'm concerned with.
That should be the next project, Google Receipts API.
David?
So you were saying that the Android Vision can't detect anything outside of humans?
Pretty
Maybe
much,
one
yeah.
other animal,
Yeah.
possibly? Does that mean that can OpenCV be configured to scan for any features and you could customize it to pick up like?
You have to train it on certain inputs. We had done a project before at my front with dogs. And we didn't get very far with it, but it would be possible with OpenCV to do something like that.
So how accurate is the dog detection? Your neighbor's dog versus your dog, there's probably a difference?
You wouldn't be able to tell the difference, but whether it was our dog or not, that was kind of up in the air.
The main problem there is primarily the image quality, really contrast, right? Like
Depends on the position of the dog.
the position of the dog and on a noisy background, outlining an object, any object, whether it's a dog or any object you're trying to detect with OpenCV as like computer library, it has a lot of trouble finding the beige dog against this beige wall.
Does it help if your background is always the same, and you're only introducing the same object, the same, different dog with the same background?
I think
Absolutely,
as
yeah.
long as the contrast is enough, yeah.
If it's like a white background, yeah, you draw the dog.
Any other questions? Yeah.
Would you have a hard time detecting the, for example, when we are making an email address or something, you have to punch in the letters?
Yep.
And they are scrambled up and we have to see it and then. So, would you have a hard time detecting that?
In barcode or just in?
No, not the barcode, not even, just some simple letters.
The API won't even detect that. All we'll do right now is spaces and barcodes, yeah.